wrote a whole long thing about how to simplify Boolean expressions, but I'm realizing that it was probably way too long, and I could probably demonstrate more easily and also more a sort of shorter path to simplifying complex Boolean expressions. So I want to start with sleep in, same function I wrote about, and I'm starting from a version of sleep in that works. As you can see here, I can run the tests and it works. This is, I think several of you wrote something very much like this. I think the comments are mine, but the rest was basically there. And it's a very reasonable way to write it, given that there's only 4 possible ways that the arguments can be combined. So we basically just exhaustively handle all the different permutations of true and false for the arguments. However, I want to show how we can make this a lot simpler and using some rules that will apply in other bits of code where it isn't as easy to just exhaustively solve all the possibilities. So the first thing I want to do is notice that whenever we compare a variable like weekday, which is going to contain a Boolean value, i.e. either true or false, with a literal true, that's not really doing anything, because it's basically saying, is true equal to true, in which case we get true, or is false equal to true, in which case we get false, i.e. we're always getting the value of weekday. So in some sense, if you're going to write this, you might as well write this, like check again that it's still true. But instead, what we should do is anywhere we compare directly to the literal true, just use the variable, because it's already true or false, which is exactly what we're going to get out of doing the comparison. So I can just take all these equals equals true off. That's all of them. Hit run. Test till pass. So that's great. Similarly, whenever we're comparing to false, the value we're going to get from this comparison, equals to false, is the opposite of the value of the variable. So if vacation is true, true is not equal to false, so this will be false. If vacation is false, this will be equal and it will be true. So the easier way to write that is with the not operator. So everywhere we compare directly to false, we should instead use the not. And one of the biggest reasons to do this, other than that it's shorter and arguably clearer, is there's a risk if you use this equals, if you accidentally type 1 equals, this expression now has the value, you're actually doing an assignment, and this will always be false. Because weekday is just a variable, it gets assigned the value of false, and the value of that assignment is the value. So that's just a risk that you can run into, and it's avoided by simply never comparing to Boolean literals, true and false. So we can take all those off, and so now the code is already shorter in the sense of fewer total words. Okay, next up, whenever I see a chain of ifs like this, and I wonder, are these actually, can any of these happen? Could they all happen? Because writing them separately suggests that maybe they could. But in this case, the whole point is that these are all mutually exclusive options. So we should really chain them together in a sort of single if, else if chain, because that just makes it really clear to the reader, i.e. us, that only one of these branches is going to happen. We're either going to be in the weekday and vacation branch or the weekday and not vacation branch, and so on. So just to prove that that's equivalent, test till pass. Okay, I'm going to delete these comments just because they're getting in the way a little bit. All right, so we can just sort of see exactly what's going on. Okay, now the next thing that I would look at is I look at these two branches and notice that they both have weekday and something. And so I can make an if for just that. Where do I want to put my brace? Here. So now I'm going to hit auto format to make sure I've done this properly. Okay, so now I have if it's a weekday, then do these two branches. And since we've now checked outside, we can take off the condition that it's the weekday. And this starts to look nice because now we see that the branch of if vacation and if not vacation, well, if we go down this branch because vacation is true, the only other possibility is not the vacation. So now we don't even need this test anymore. Prove that that's still working. True. Or yes, test pass. Okay, now we get to one of my other favorite simplifications, which is whenever you have an if statement on a boolean, where the test is a boolean value, and then you return true or else you return false, well, this is kind of like comparing to literals. This is already true or false. And if it's true, we're going to return true. And if it's false, we're going to return false. So we can actually replace this whole thing by just returning the value of vacation. Okay. And so now we can do a similar thing. I can basically wrap this whole expression, the other branch, in a, so if weekday, else we're in the not weekday. We can take that off the inner conditions because we've got it wrapped up out here. We can then also notice that now this actually only has two branches. It has the if the weekday, else if not the weekday, and by the same argument as before, we don't need that test anymore. So now we're down to if weekday, return vacation, else. And this is a funny one. If vacation, return true. We can sort of do the same thing, take off the if not vacation. But regardless, we're going to return true in either case. So this whole set of things here always boils down to returning true. So we can just return true. And now there's one last step that's maybe a little less obvious, but I'm going to do it this way. So one thing we can always do when we have a sort of a simple if-else like this is we can reverse the test, meaning flip its Boolean value, from which we, as we talked about before, we do with the not operator, and then swap the code in the two branches. Right? Because it used to be, if it was weekday, we would do the first branch and otherwise the second branch. Well, now we're flipping the instead of weekday, we're doing not weekday, so we swap the two branches. So this is logically the same. Test still pass. And the reason I did that is because now we can look at this and say, okay, so if, what can we say? If it's, so if the value of not weekday, collectively, i.e. when weekday is false, so not weekday is true, we're going to return true. So let me just start writing up here. So what if we just said return not weekday? So that would be wrong because that would just go by the one value. However, if this thing, not weekday, was not true, then we'd go into this other branch. And that's the same as saying, so if this thing is not true, then we want to return a different value. And that's what the OR does. So it basically says, if this first part is true, just return it, or return the value of the thing after this OR operator. So this line here is equivalent to these, basically. If this is true, return true, or return whatever the value of vacation is. So if we delete that, hit run, I think it ran. Is it running? Alright, Replet's doing its thing. Alright, I don't know. Replet's having a sad reload just so I can prove. Oops, I didn't get that change. Alright, delete that. Hit run. Good. Still passing. So now we're down to a much simpler version of the function that we've proven every step of the way is equivalent. And also, as I noted in the very long thing that you probably didn't read, which is understandable, this is, if you look back at the problem statement, the definition of when we're allowed to sleep in is almost literally, it says we can sleep in if it's not a weekday or we're on vacation. So this is a very direct expression of the value that we were trying to compute. So it's fine to start at the what we had originally. It was 100% correct, but this is and so you can get to something like this by this sort of process of simplification, which it's good to be able to do because sometimes code will get complicated, and then you can look at it and see actually it's a lot simpler than I've made it. After a while, you get used to these kinds of things, and you might write this. Given that problem statement, you might be like, oh, I'm just going to compute a Boolean value from two other Boolean values, and what's the logical relationship? And it's this. So anyway, that's a lot shorter than the written version. The written version does go into a bunch of other techniques that, if you really want to get into this stuff, might be interesting, but the key point is to these few techniques that don't compare to literals, factor out the common. So when we had if and two different branches that both happened only when weekday was true, we could factor that out. Getting rid of redundant else ifs, but using else if to chain things together. So those are kind of the 3 points. Anyway, hopefully this was useful, and thanks for watching.